7.4, solving systems of equations with elimination method. Now this is the second day of it with multiple steps. So yesterday we learned that SOAP stands for S-O-A-P. You need to put it in standard form, which is AX plus BY equals C. Then you want to multiply one or both of the equations to get opposite coefficients. And remember, that is either the x or the y. It doesn't need to be both. You're just going to pick one column to get opposite coefficients. Then you add down and you'll solve. And then once you've solved for one variable, then you plug it back in to get the other variable. So let's go ahead and try these. It says, so yesterday we only had to multiply one equation by something. Today we'll have to multiply both equations by something. So you want to double check that they're always in standard form. Many times they're already in standard form for you. Like this one is already in standard form. You see the column of x's, the column of y's, and then you've got a column of whole numbers on the right side of the equal sign. So that part's done. Now we want to get opposite coefficients. Now in order to figure out what your opposite coefficients are going to be, you look at 3 and 5 and you say, what do 3 and 5 both go into? They both go into 15. 4 and 2 both go into 4. So you want to make a choice. Do you want to get these both to be 15 or these both to be 4? Now for two reasons, I would pick the y column. The first reason is because 4 is much smaller. But the second reason is that we already have one 4, and we just need to get this one to be -4 so that they're opposites. So if my goal is to get a 4 in this column, in this case I already have a 4 in this column, so I'm just going to rewrite it to the right. 3x plus 4y equals 6. This one we need to get the opposite of +4. And in order to do that, we're going to have to multiply the entire equation by -2 so that we'll get a -4 here. And you have to be sure that you multiply every single piece. So we get -10x, -4y, and negative times negative gives us +8. Now we have opposite coefficients in the y column, either the x or the y. We did the y's this time. Now just add down. 3x plus -10y is -7x. These will drop out. That's why it's called elimination method. Equals 6 plus 8, which is 14. Then we keep solving, so we divide both sides by -7. We get x equals -2. Now remember, these are two equations. They've got an x and a y. We're looking for where the two lines would intersect. So we need a full point in x and a y. Right now, all we have is the x. So we still have to go back and plug this x back into one of these two equations. It doesn't matter which one. So let's suppose we use the bottom one just because it's the most handy. And we plug 5 times -2 plus 2y equals -4. You rewrite the exact same equations, but instead of x, we put -2 in its place. And now we're going to solve for y. So this gives us -10. We need to move the 10 over by adding 10. We get 2y equals 6, and when we divide both sides by 2, we get y equals 3. So the coordinate where the two lines would intersect if we were doing graphic method would be -2, 3. All right. Moving on down, we can try another one here. This one's not in standard form, so we need to take a step to put it in standard form by adding 3y to both sides. So -5x plus 3y equals 6. And this one is in standard form, so x minus y equals 4. One thing about standard form, there is the rule that the x has to be positive in true standard form, but this is kind of like a relaxed standard form. It does not need to be positive. So as long as you've got it in the right order and there are no fractions, then that is enough for this particular type of problem. So we want to get, we've got a 1 and a 5. 1 and 5 both go into 5, or 1 and 3 both go into 3. So you can choose 5 in the x's or 3 in the y's. Again, I'm going to choose the 3 because it's just the smaller number. And we already have a 3 in this one, so we don't have to change it at all, just rewrite it. This one, however, has a negative 1. And if we got a positive 3 here, we're trying to get a negative 3y in the other one. So in order to get a negative 3y here, I've got to multiply the entire equation by 3. So now 3 times 1x is 3x, 3 times negative 1y is negative 3y, and 3 times 4 is 12. We have opposites now in this column, positive 3, negative 3. So when we add down, those will drop out. Negative 5 plus 3 gives us negative 2x equals 18. Divide by negative 2, and we get x equals negative 9. So that's your x value. Make sure you put it in your x slot. Now we have to find the y. Again, this one would be the better choice this time because it has smaller numbers, but you can choose either equation to plug it back into. It does not matter. So I've got negative 9 minus y equals 4. Solve for y, so we add 9. Negative y equals 13. Divide by negative 1, so y equals negative 13. Remember, you can pause, rewind, as often as you want if I'm going too fast. Moving on down, what if you can't get opposite coefficients by multiplying only one of the equations by something? So let's start this one from the beginning. This one is in standard form already. 3x plus 4y equals negative 25. This one we're going to need to move the 3y over by subtracting it. So we get 2x minus 3y equals 6. Notice I keep moving across. I just think it's easier to organize your information if you're moving across until that point where you add down. So there's less confusion. Now we've got a 3 and a 2 in this column, which could give us 6's in the x's, or 4 and 3, which could give us 12. So 3 and 2 both go into 6, 4 and 3 both go into 12. Neither of them do we already have one of those. So 6, we don't have a 6 here. 12, we don't yet have a 12 here. So again, I'm going to choose the smaller one just because it means if I'm shooting for a smaller goal, the numbers will continue to be smaller. So I need to multiply this by 2 if I want to get a 6x in this column. So 6x, multiply everything, plus 8y equals negative 50. Multiply 2 by every single piece. So I've got a 6x here. I need to get a negative 6x, so I have an opposite. So right now I have a 2. What can I multiply 2 by to get negative 6? That could be a negative 3. So 2 times negative 3 will give me negative 6x. Negative 3 times negative 3 gives me positive 9y. And 6 times negative 3 equals negative 18. We go to add down. This time, it's the x's that drop out. So it just differs depending on the problem. 8y plus 9y is 17y. Negative 50 minus 18 is negative 68. When we divide both sides by 17, we get y equals negative 4. You need to be very careful because if you accidentally put 4 here, when you go to do the second half of the equation, you'll get the wrong answer in the second half as well. So watch your signs. Negative divided by a positive is negative. Now that is the y value, so you need to make sure you put that in the second half because that's where your y goes. And then we'll go back here. I'm going to go for this bottom equation again. You have a choice, but that's the one I'm picking. 2x equals 3 times negative 4 plus 6. Just take that negative 4, plug it in for that y. Do the math. 2x equals negative 12 plus 6. 2x equals negative 6 when you add these together, and x equals negative 3. There you go. Now, they continue to be the same, so we just keep doing the exact same thing. We do have some special cases, so you could go ahead and try number 3 on your own. Number 4, we'll go ahead and do together here. This one's in standard form already, 3x minus 5y equals 15. This one, however, it looks funky. It's not in standard form because the x needs to be moved to the other side. So we move the 6x by subtracting it. So we get negative 6x plus 10y equals, nothing's left on this side, so you have to make sure you put that it's equal to 0. Now we look at our two columns. 3 and 6 both go into 6. 5 and 10 both go into 10. I'm going to choose the smaller one as usual, and lucky for us, this one is already a -6. So we'll rewrite that one. But this one is a 3. We need the opposite of -6x, so we need a positive 6x. What can I multiply 3x by to get positive 6x? I can multiply that by a positive 2. So I get 6x minus 10y equals 30. And what happens when we add down? Well, these guys drop out. So do these, which means there's nothing left on the left side. Nothing in math terms is 0. And 30 plus 0 gives us 30. So you have to look at this. We've done this when we solved equations. When all the variables drop out, you have two possibilities. It can be many solutions, or it could be no solution. This particular statement is false. You don't need to write false. This is just a thought. But if it is false, not true, then think that's bad. That means we're going to get no solution. Now, why would we get no solution? If these both represent a line, how could they possibly not cross each other? Because remember, the solution is the place where they intersect. So if we're getting no solution, that means they never intersect. Then what would be going on? The only types of lines that never intersect are parallel lines. So anytime you say no solution, you also need to write parallel lines. So we know why we're getting no solution. Okay. Last one here, number 5. We need to put this in standard form. This one's already in standard form. 2x minus 3y equals 2. This one is going to be add 5x to both sides. So we get 5x plus 4y equals 28. Here I could get 5 and 2 go into 10. 4 and 3 go into 12. And again, I'm going to go with the smaller one for sure, so 10s. So let's look at the first one. What can I multiply 2x by to get 10x? I could multiply by 5. So that'll give me 10x minus 15y, equals 10. On the bottom, I need a negative 10x. So I'm going to multiply this whole thing by negative 2 to get a negative 10x here, a negative 8y here, and a negative 56 here. So now we've got opposites here. When we add down, they drop out. Here we get negative 23y equals negative 46. There are variables here. As long as there are variables left over, you keep going, solving for that variable. So we get y equals a negative divided by a negative with a positive 2. That's your y, so that goes in the second piece. I'm going to go here and figure this one out. 4 times 2 equals 28 minus 5x. That's 8. Just rewrite everything else. Subtract 28, and I get negative 20 equals negative 5x. Divide by negative 5, we get 4 equals x. One final thing. We talked about what happens if you get a false statement. But if you get a true statement, we'll write that at the bottom. Okay? If you get a true statement like 0 equals 0, that's true. So that means you'll get many solutions. So how could two lines intersect in multiple ways? The only possibility is if you have one line, and when you go to graph the other line, it's right on top. So every single point along those two lines will intersect. So we don't want to say infinitely many or all the reals. We don't want to write all the reals because all the points don't work, just the points along this line. So we write many solutions, and then you describe it as the same line, because the two lines, in order for them to share all of these points, would have to be the exact same line. So anytime the variables drop out completely, decide if it's true or false, like the previous one, If it's true, it's many solutions, same line. If it's false, it's no solution, which means they are parallel. And you can go ahead and write those two on your Cornell sheet. True gives you many, same line. False gives you no solution, parallel. So that you can put on your Cornell sheet. You can also put soap on your Cornell sheet if you have not filled that into your Cornell sheet.